Hi there, and welcome to this lesson on Pure Mathematics 4. In this lesson, we're on Chapter 7, and the first part of an introduction to vectors. First of all, what's a scalar quantity? Well, a scalar quantity is a quantity like speed or distance that only has a magnitude or a size. So, for example, you could have a speed of 50 kilometers per hour or a distance of 100 miles. But all you know is how fast you're going or how far you've gone. You don't know the direction that you've been going in. A vector quantity, like velocity or displacement, has both a magnitude and a direction associated to it. And vectors can be represented by a line segment with the appropriate magnitude and direction. So, for example, if you had the vector PQ, that would represent the vector which begins at P and ends at Q. And you'll notice that the arrow points from P to Q, both in the drawing, it's pointing from P to Q, and when you write down the vector, it goes from P to Q. Whereas the vector QP represents the vector which begins at Q and ends at P, with the arrow pointing in the opposite direction. Small lowercase letters are used to indicate vectors. In print, these are normally written in bold. So the vector from P to Q, you could write it in two ways. You could write it as PQ like that, or you can write it as a small letter. Now, in textbooks and exam papers, they'll use a bold letter to indicate that it's a vector. If you're writing by hand, it's not convenient to write in bold. So the normal notation, if you're writing by hand, is to have a small line underneath the letter. And that line is normally a curvy line, which indicates it's a vector rather than any other constant. If two vectors are equal, so for example, if PQ is equal to RS, then the vectors have got the same magnitude and they're in the same direction. They're parallel to each other and they've got the same size. But they don't have to be in the same position. So the vector PQ, the vector RS, they will be exactly the same as each other. If PQ is equal to the vector A, RS is also equal to the vector A. It's identical. To find the vector between one point and another point, what you have to do is find any route that starts at the beginning point and ends at the finish point. It's a bit like just taking a journey through a town where you know where you're starting from, you know where you're finishing, and you've got to work out what roads you'll go along to get from the start point to the finish point. And you need to know the vector for each portion of the journey. So, for example, if we had this shape here and we knew OQ was equal to A, QS was equal to B, and the vector from R to S was equal to C, and we were asked to find these three vectors, the vector that goes from O to S, S to R, and R to O, looking first of all at the vector from O to S, the origin, O is the start point, and we've got to get to S, that's the finish point. There are two ways you could get there. We could go from O to R and then go from R to S. The problem with that route is that we don't know the vector from O to R. So instead of doing that, we'll go from O to Q and then from Q to S because we know both vectors along the way. And you do just add the vectors together. So the vector from O to Q is A, the vector from Q to S is B, and we'll just get A plus B. That's the answer they're looking for. Okay, I'll let you have a go at finishing all the rest of this question. So pause the video, have a go, and come back to me when you're ready. Okay, let's have a look at this. So as we said, the vector from O to Q is A, the vector from Q to S is B, and we're just adding those together. So the vector from O to S will just be A plus B. The vector from S to R, well, to get from S to R, I need to go along this vector, but you'll notice that the vector from R to S is C. That means the vector from S to R is going backwards along C, and we do what you'd expect you do. We just write that as minus C. And then the third question, the vector from R to O. Well, R to O is obviously the shortest route to get there, but we don't know that vector, so we're going to have to go the long way round. We'll go from R to S, then from S to Q, and then from Q to O. From R to S, that's the vector C. From S to Q, that's minus B, because we're going backwards along the vector. And Q to O, that's minus A, because again, we're going backwards along the vector. So that would give us C minus A minus B. Okay, example 2 is exactly the same idea. I'll let you have a go at working your way through the whole of this yourself. So pause the video, come back to me when you're ready. Okay, let's have a look. So first of all, the vector from O to S, and again, the easiest way to do that is from O to Q and then from Q to S. We know both of those vectors. So the vector from O to S will be A plus C. And then the second question, the vector from Q to R. We can't go from Q to S and then S to R because we don't know that vector between S and R, but we can go from Q to O and then from O to R. And that'll be minus A for the first part and then plus B for the second part. So minus A plus B, or you can write it the other way around. If you want to write it as B minus A, that is fine. You don't have to be strict with saying which vector did I do first, which did I do second. The vector from R to Q, same vector, but in the opposite direction. So this time it'll be minus B and plus A. So minus B plus A or A minus B. And then the vector from S to R. So we'll have to go from S to Q, then Q to O, and then O to R. And that'll be minus C, minus A, and then plus B for the last leg of the journey. Okay, example 3 is quite a bit more confusing. We've got a parallelogram now. That matters. It means that OA is parallel to CB. So the vector OA equals the vector CB. And similarly, AB will be parallel to OC. So the vector OC is S, the vector AB will also equal S. And 2 other things we're told. We've got the point M here, which is the midpoint of CB. And more confusing than that, we've got the point P, which divides AB in the ratio 2 to 3. So if the whole of AB was 5 units long, from A to P would be 2/5 of the whole distance. From P to B would be 3/5 of the whole distance. Now, bearing all of that in mind, you'll be having fractions involved in the question. Now, have a go at finding these 4 vectors. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So first of all, the vector from O to M. Well, to get from O to M, I'm going to go, first of all, from O to C, and then I'm going to go from C to M, which is half the distance from C to B. So O to C, that's straightforward enough, that's just S. And then to get from C to M, I need to do a half of CB, which is a half of the vector R. So it'll be S for the first bit, plus a half of R for the second bit. Second question, from O to P. Well, I'll go from O to A, and then from A to P. Now from O to A, that's straightforward enough. That'll just be the vector R. To get from A to P, that's 2/5 of the whole of the vector from A to B. So it'll be R for the first bit of the journey, and then 2/5 of the vector S for the second part. To get from A to M, the route I'm going to take is from A to O, and then O to M. And the reason why I'm doing that is A to O is easy, that's just minus R, and O to M I already know, I've worked it out. So A to O is minus R, and then from O to M, it's the answer I worked out here, S plus a half R. And you add vectors just like you would do with any normal algebra, so that does tidy up to give us S minus a half R. And then lastly, the vector from M to P, well, this is the most confusing one. The way I'll go there is I'll go from M to B first of all, and then from B to P. Well, M to B, that's half of this, so it's half of the vector R. And then from B to P, it's going to be 3/5 of the vector from B to A. Now, a half of R for the first bit is okay, and then 3/5, we need to be a little bit careful, it's minus 3/5 of S, because S would be the vector from A to B, and I'm going backwards. I'm going from B to A. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 101 and have a go at exercise 7A. Thanks very much for listening, and cheerio.